Electric charges are conventionally called positive and negative charges, and that like charges repel each other and unlike charges attract each other. However, if the size of the charged body is very small but the distance between them is comparatively large than their size, such charged body are treated as point charges. SI unit of electric charge is coulomb. However, smaller units like millicoulomb and microcoulomb are also used in electrostatics. Electric charge is a scalar quantity, which means it has only magnitude but no direction. Total charge on a body is always equals to the algebraic sum of the individual charges given to it. Let us explain with an example. Consider a body carrying a charge, say Q1. We add another charge Q2 to this body. Now, total charge on the body is the algebraic sum of both the charges. That is, total charge is Q is equals to Q1 plus Q2. Similarly, if a body carry n number of charges Q1, Q2 and so on up to Qn, then total number of charge on a body Q is equals to Q1 plus Q2 plus Q3 up to Qn. While adding the charges, proper signs should be used. A positive sign for positive charges and negative sign for negative charges. We can determine whether a body is charged positively or negatively by finding the algebraic sum of all the charges on the body. For example, if a body is given 6 charges all in coulomb, say plus 1, minus 2, plus 3, minus 4, minus 5 and plus 6, the algebraic sum should be minus 1, which means it is negatively charged body. When a glass rod is rubbed with silk cloth, electrons are transferred from glass rod to silk cloth. That is, now both the glass rod and silk cloth are charged. Here, there is simply a transfer of charge takes place. Neither a new charge is created nor any charge get destroyed. That is, the total number of electron lost by glass rod is equals to total number of electron gained by silk cloth. If we consider a glass rod and silk cloth is an isolated system, then total charge of this system before and after rubbing remains same. Therefore, we can conclude that charge on isolated system always remains conserved. Charges are also conserved in natural processes such as beta decay of neutron. During beta decay, neutron breaks into a proton and electron, releasing a neutrino. Here, neutrino and neutron are chargeless particles, while proton and electron are opposite charge particles, whose combined net charge is zero. Here, we observe that total charge in this process is conserved. The charge on an object is always an integral multiple of E. This property is called quantization of electric charge. The magnitude of this basic unit of charge E is equals to 1.6 into 10 to the power minus 19 coulomb. In an atom, when we refer to the charge on a proton, its value is positive and referred to as plus E, where the value of E for a charge on an electron is negative and referred to as minus E. Thus, charge on an object Q is always equals to the product of number of electron gained and lost by it and the basic unit of charge, that is Q is equals to Ne. Now let us calculate number of electron 1 coulomb of electric charge carry. Consider a body having a charge Q equals to minus 1 coulomb. Let number of electron it can gain to become negative charge is N. Then, according to quantization principle, we have Q equals to Ne, where E is equals to 1.6 into 10 to the power minus 19 and Q equals to minus 1. Substituting the value of E and Q, we get Ne equals to minus 1. On solving, we get N equals to minus 6.25 into 10 to the power 18. Here, N is a negative integer, indicating that body has gained a negative charge. So, we see that 1 coulomb of negative charge contain 6.25 into 10 to the power 18 electron, which is a very large number of electrons. Now solve one question. A body has given plus 2 coulomb of charge and body Y has given minus 2 coulomb of charge. Can we say that X has more charge as compared to Y? The answer is both X and Y have same amount of charge. Only they have opposite nature, one having positive charge and one having negative charge. Now solve another question. A body has positive charge on it. Then does it mean that it has gained some protons or lost some electrons? The answer is if the body is positively charged, then it means that it loses some of the electrons. Next question, define polarity of a charge. The property which distinguishes the two kinds of charges, that is positive or negative, is called polarity of a charge. Let us now study about conductors and insulators. Since we know that atoms are the basic building blocks of all matter. In an atom, proton and neutron are the main constituents of nucleus, while electrons are revolving in orbit around the nucleus. For some materials, generally metals, the electrons in the outermost orbit are loosely bonded to the nucleus, and these electrons are called free electrons. These electrons are free to move around the material. Such materials having large number of free electrons are called conductors, and as such these materials readily allow the flow of electric current through them and cause very little resistance to the flow of electricity. Some example like copper, nickel, human body and earth, etc. are some conductors. Some material having very small number of free electrons and offer very high resistance to the flow of electricity through them. Such materials are called insulators. Some examples like propylene, plastic, Glass, wood, and nylon are some insulators.